to mention this. So really what we're trying to do is kind of dial the clock backwards and say, when did it begin ticking? If we take all the differences in this room, how many generations would it take to dial back 60, another 60, another 60, till we're back to Noah and his family? What we need, though, is a single starting point. If I say the time now, as this clock shows, is 12 minutes to noon, how long has the clock been ticking? If I say the time is 12 minutes to noon and it started ticking at 11, you could easily calculate how long it's been ticking. If I say the time is 12 minutes to noon and the clock started ticking at 11 or 10 or 9:30 or 8:15, how long has it been ticking? Well, now you got a problem. The fact that all of us have 2 copies of a DNA sequence means there are multiple starting points. So here's a good time to stop and define terms. How do we know what's a mistake, what's a variant, what's a mutation? It's really kind of a guess. If we've got father-son, it's fairly easy. You sequence both copies of dad's DNA, you get the sequence there, all 6 billion letters, 3 billion times 2. Then you get both copies of son's DNA. Actually, you need mom's as well. And if son has certain letters that neither of his parents have, well, then you can say these must be new. These must be mistakes. He can only get DNA from his parents. He didn't get them from aliens or from someone else. So these must be mistakes. Now, son's going to be different from each of his parents, but you can probably trace so these have a kid. I need a different diagram. I'm talking spontaneously, so I'm not prepared for this. So I'll just back up here. There it is. So this son has 2 copies. You can compare this copy to both the grandpas and grandmas, and you might find, you'll find nearly all of those letters in one of these parents. You look at this copy, you'll find nearly all the letters in one of these parents. Some of these letters you won't find in either. Now, they all use the same alphabet, but some of the misspellings, if I can call it that, you won't find in either. Okay, those must be mutations. Those must be mistakes. However, this guy is going to look different is going to have DNA different from his wife, because she inherited her DNA from some parents we haven't even shown on the screen, and they look different. So there's really 2 sources. If you compare 2 people, there's 2 sources of differences. I compare you to me. We're going to be different, not because one of us is more mutant than the other. It's because we have different parents. So that's the key point here. Some of the differences among humans are pre-existing. Some of them actually come from mistakes, this process of 60 changes over time. So I need to clarify that. Now back to the slide that I was on. So that's why I'm bringing up this point. We need a single starting point. Some of the differences among modern humans will go back to differences that Noah and his wife had. Some of the differences we see will be due to mistakes, copying errors. So we're not going to look at most of the DNA sequence. There's only 2 sequences. I'm just going to jump to the conclusion. There's only 2 types of DNA sequences we can look at, the Y chromosome and the mitochondrial DNA. And don't let the terms intimidate you. I'll tell you about them in a moment. So I mentioned in one of the previous lectures, all of us have 46 chromosomes, 23 from mom, 23 from dad. We're all male or female. That's encoded in your DNA as well, and it's signified by your chromosome number. Females are XX, that's just the notation we use. Males are XY, not YY. So that means Mrs. Noah had 46 chromosomes and had an X and an X. She's female. Noah had an X and a Y, and he's male. So at the time of the flood, this couple had a single Y chromosome. So Noah has 2 copies. He would have had chromosomes 1 through 22 from mom plus an X, and 1 through 22 plus a Y from dad. She would have had 1 through 22 plus X, 1 through 22 plus X from each parent. So these sons, born of Noah and his wife, would have gotten their Y chromosomes from who? From Noah. So that means, since these guys are progenitors of all the males on this planet, all the Y chromosomes go back to a single starting point, Noah. You might have heard the term in the news, Y chromosome Adam. From a biblical perspective, we're really talking about Y chromosome Noah. because all the other Y chromosome variation was lost at the time of the flood. What about mitochondrial DNA? So last night we talked about these little energy factories called mitochondria. They also have a tiny little DNA sequence. So most of our DNA, 3 billion letters times 2, is in a different compartment. Mitochondria will have a little section of DNA only about 16,000 letters long. So it's really tiny compared to 3 billion. Males need to generate energy. Females need to transform energy. Both of us have it, but only moms pass it on. So my wife and I just had a 1-year-old little boy. He needs to generate energy, but he got his mitochondrial DNA from my wife, not from me. I got mine from my mother. So Noah and Mrs. Noah both had mitochondrial DNA, but only mom passes them on. So where did the boys get their mitochondrial DNA? From Mrs. Noah. Where did their wives get their mitochondrial DNA? From their mom. So there's another source. The Bible doesn't say, sorry, that's supposed to be read, that these ladies were sisters or daughters of Mrs. Noah. So to be safe, we have to assume then that their mitochondrial DNA goes all the way back to Eve. By the way, so these guys get their mitochondrial DNA from mom, and that's the end. No more Mrs. Noah lineages. Why? Because they marry, and now their wives pass on mitochondrial DNA, and so Mrs. Noah's sequence, her DNA, is lost. So these ladies go all the way back to Eve. So to talk about mitochondrial Eve is legitimate. That's a term that's tossed around. We want to use genetic differences as a clock. We've got 2 sequences now that have a single starting point, Y chromosome and mitochondrial DNA. What we need then is a rate of change. I talked about 60 mutations, differences happen from father to son, mother to daughter. That's not been measured specifically for the Y chromosome. It has been measured specifically for the mitochondrial DNA. So that's what I'm going to focus our attention now and talk about the clock. So thinking from a biblical perspective, how does DNA act like a clock? We're looking at mitochondrial DNA. Eve was created with some, Adam was created with some. They have children. Adam is lost because he doesn't pass it on. Only Eve does. Passes it on to her children. And that DNA changes a little bit over time. So these different ethnic groups around the planet will have slightly different mitochondrial DNA sequences. And now here's where the math comes in, and you only need to know one equation. This is the clock. So Eve starts with a created sequence. There's no differences because there's no one to compare to. It's just what God created her with. Over time, it gets passed on, and a mistake happens, and a mistake happens. So the more generations that pass, the more differences accumulate. So if we were to get the mitochondrial DNA sequences from each one of you, they're a product of your history. The amount of times, the number of generations that have happened, that's sort of the time factor. How long have we been here as a species? And how fast does that rate occur? That'll give us the number of differences we see today. And again, from an evolutionary perspective, humans have been here a very long time. The female ancestor of the modern human race, evolutionists say, goes back to 180,000 years. Before that, they say they were just proto-humans. But modern humans, they say, 180,000 years ago. That's when she lived, the female ancestor. And so they'll say, with humans having a long history, should there be a lot or a few differences among modern humans today? A lot. So lots of time here means you're going to have lots of differences today. Eve was created 6,000 years ago, according to Scripture, which means there should be, by comparison, fewer mutations, fewer differences among the humans we see today. Well, we don't have to just stick to little arrows. We can actually put numbers to this. This rate has been measured. How do you measure the rate of change? You get a maternal lineage, grandma, mother, daughter, and measure how many changes happen each generation. Plug that number in, multiply it by 180,000 or by 6,000, and you'll get a number. And this is what it looks like. So 180,000 years times the number of changes that happen per generation. Evolution predicts that after 180,000 years, there should be 175 or so differences among us today. There's always variation with biological measurements. So these black bars represent the maximum possible range. It could be as low as 124. It could be as high as over 300. But it doesn't get anything beyond that. This is the average prediction. So the best case scenario for evolution, 124. The creation model, so again, I use 10,000 years just for a round number to get an upper estimate, says that about 10 differences should accumulate after 10,000 years. There's again a range, 7 to 16. And here's the actual number of differences. This is a subsection of the sequence, but I'm comparing apples to apples here, so to speak. This is the actual number of differences, this green, supposed to be green-looking bar. And there's a range, again, depending on which part of the world you're looking at. So the point here is humans have very few differences today. That's exactly what the creation model predicts, and it's far too low for evolution to be true. Now, it's not just humans for which this story is true. There are 3 other species for which the rate of mitochondrial DNA change has been measured. So here are 3 species. They all need to transform energy. They've all got cells. They've all got mitochondria. And they get passed on through mom. So this is a water flea. It's actually classified as a crustacean. So it's classified with crabs and lobsters and such. Fruit fly and a roundworm. So let's do the same sort of calculation. From a creation perspective, God created water fleas. Now my guess is, since you need a microscope to see these guys, God didn't create just 2. When he created the world, he probably put water fleas all over the planet. But just for sake of argument, let's keep it simple. Let's say he created 2. These guys reproduce for 6,000 years, and mistakes happen each time. And so if you look at modern water fleas, there should be some differences among them. And again, if water fleas have been here a very long time, millions of years, there should be a lot of differences. Same type of equation, but this time plugging in the rate of change for water fleas. So a lot of differences if they've been here millions of years. According to evolution, very few differences if they've been here only 6 to 10,000. So here's the predictions again. So evolutionists say these guys originated 7 million years ago. 7 million years of reproducing, of change, of reproducing, of DNA mistakes should give you, on average, 140,000 differences. Now I said the actual sequence is only about 16,000 letters long. What this means is these guys should have changed and mutated every single position in that sequence multiple times over. How are these poor little guys going to survive, let alone remain the same species? And a tiny little bit of differences into the creation model, 162 to 210. The actual number of differences among these guys on average is about 646. Now this difference doesn't bother me. Again, we made the assumption that all water fleas came from 2, which is probably not accurate. And this is a tiny difference compared to that difference. This is 1,000 times too high. That's a real problem for evolution. Well, let's do the same thing now for the fruit flies. Again, God probably didn't create a single fruit fly when he created plants and created animals in days 3, 5, and 6. He probably created multiple ones. But let's pretend it was 2. So fruit flies have been reproducing and accumulating DNA differences because mistakes happen for 6,000 years. Evolution says they've been accumulating differences for 20 million years. So we have a mutation rate. We have the time from evolution, the time from creation. Evolution says 20 million years of change. There should be a whole bunch of differences. Creation, 6,000 years of change, very few differences. Don't be intimidated by this black bar again. This is just the maximum possible range. So the evolutionists predict 20 million years, after 20 million years of change, 500,000 differences. Again, mutate all 16,000 positions multiple times over. The lowest they can predict is 98,000. And the actual number of differences is less than 2,000. There's a range here again, and it matches what the creation model predicts. So 98,000 is 100 times off, too much, from 150 to 2,000. Roundworms, you can probably guess the story. God creates one or several, we'll assume 2. These guys reproduce and change over time. They accumulate differences. Evolution says they've been doing it for a very long time, so they should have a lot of differences. So the evolutionists say 18 million years, 18 million times this should give you a fairly big number. 6,000 times the mutation rate, a small number. There's your numbers again. The actual number difference is about 1,600. right within the range that the biblical model predicts. Evolution says they should have accumulated 2.5 million differences. These poor little guys having to endure all those mistakes. So this is way off. And the best guess, 1.7 million. That's incredible. 10,000 times off. Now, what are the evolutionists going to do? They can't seem to be able to predict how much genetic diversity, how many genetic differences exist in species today. Their time scale is way off, and the flip side of that is the biblical time scale gets it right. And we're using evolutionary assumptions. I'm assuming the rate of change has been constant for the last 6,000 years. I'm assuming it's been constant for 18 million years for evolution. So what's the first thing they might be tempted to do? Assume the rate has changed, that maybe that rate slowed down, and it only has sped up recently. Well, there's a problem with that. First, it'd be hypocritical, because in geology, what do we assume? Constant rates of change, constant rates of change, constant rates of change. So it's only fair to assume the same in biology. Second problem is, well, we can calculate how slow these rates of change need to be, and it's virtually impossible. So let me explain what these numbers mean. Those are years. And so it's saying, let's pretend 18 million years ago, the first fruit flies or roundworms appeared. This says you have to wait 34,000 years before you can have one mistake. So it's got to be perfect for 34,000 years. So now we're at 17 million, however many years. Then you've got to wait another 34,000 years and you can have another mistake. It's got to be perfect. You've got to copy it perfect for 34. And this has to happen for 18 million years. That's a biological miracle. And you can see similar numbers for these other species. You've got to wait 20,000 years, and then 20,000 years, for 20 million years for fruit flies. Well, this is how much you have to wait in the creation model, and this is really what happens today. So again, of course, creation predicts numbers that are very close. Evolution's requiring a biological miracle. So what